All right. That's what I'm talking about. Thank you. All right. So we're going to start on angles. There's a lot of definitions here that I'm going to go through quickly. I was going to type them all out, but what ends up happening when I type them all out is I read them and they move quickly and you can't keep up. Okay. So an angle is the set of all points determined by two rays that have the same endpoint. And I'm going to draw them and you're going to see what I'm talking about. Okay. An angle is in standard position in the coordinate plane when the vertex coincides with the origin. Okay. So I'm going to scroll and then I'm going to come back. Do we see a coordinate plane here? When the vertex corresponds with the origin. You see what I'm talking about? Okay. The vertex corresponds with the origin. And one ray coincides with the positive x-axis. We're going to call this the initial ray, because that is where the angle is going to initiate from, where it is going to start. Okay. So the vertex is at the origin and one of the rays coincides with the positive x-axis. Do you see that? This is the initial ray on the positive x-axis. The terminal ray is the other ray. We need two of them, right? What does terminal remind you of? Other than death. It's where something ends, where it terminates, where it stops. So this is where the rotation terminates. Hence the name terminal. So if I rotate and stop, initial ray rotates. This is where my rotation starts. And this is where my rotation terminates. Do you see that? Does that make sense? Okay. So I'm going to call this angle theta. Okay. I'm going to call that angle theta. So a positive angle measure, that's a little smaller. A positive angle measure initiates at the positive x-axis, and then we are going to rotate counterclockwise. Counterclockwise. So this angle right here represents a positive angle measure. I start at the positive x-axis and rotate counterclockwise. Okay. A negative angle measure. Any ideas? So we are going to initiate again at the positive x-axis, and rotate clockwise. So let's call this theta 1 so I can tell them apart. We are going to be using, just a second. We're going to be using Greek letters to determine, to name the angles. So I have a positive rotation, and then I have the negative rotation starting from the positive x-axis and going clockwise. Okay. Now, let's call this orange one theta. What am I up to? 2. I have theta 1, and theta 2. What do we notice about theta and theta 2? They what? They're both going counterclockwise, so they're both positive angle rotations, positive angle measures. What else? They have the same terminal side and the same initial side. Would you agree? Are they the same rotation? No. What's different? This one has one full rotation more than that. How many of you have watched the Winter Olympics? Ice skating, right? So I take off. That was pretty impressive, right? Same initial side and terminal side, okay? Or stuck the landing, right? Okay? Or oh God. Oh shoot. Ooh, 10, right? Are they the same rotation? I started and stopped in the same location, but it is not the same rotation. Those are not the same angle measures, okay? So, theta here and theta 2 are called coterminal angles, okay? Because they share the same initial side, but more importantly, they share the same terminal side. Okay? Here is the AP language that goes along with this. The measures of theta and theta 2 differ by an integral, means an integer, a whole number of revolutions. Okay, so the difference between all of my little fancy twirls up here is how many additional revolutions. So here I have one full revolution and then the same. This angle measure and this angle measure differ by 360 degrees, right? Because that's one full revolution. Do you agree with that? This is the super important. Those two angles are not equal. Coterminal angles are not equal angles. I guarantee you, if I did that very first jump in an Olympic ice skating event, I would not get gold. It is very different than a triple axel or what. I know you guys would be generous, but that's because you want an A. That's not because it's actually what you think, right? Okay. So they're not the same rotation. They're coterminal, but they aren't equal. Do not use that symbol with them, okay? So, quadrants. Do you remember back in middle school? You got it? This is going to be posted also, and the video is going to be posted. So if you don't get all the definitions down, it's going to be there. Leave space for them. I want to just make sure that we get the ideas, okay? Do we remember learning about the quadrants? Okay, did anyone find it odd that when we numbered the quadrants, the order that they were numbered in? It just seems weird. Why are we starting in the upper right-hand corner? Who in the world starts there, right? So, if I were going to rotate starting at the positive x-axis and rotate counterclockwise, that's a positive rotation. What is the first quadrant I would rotate through? And then what is the next quadrant I would rotate through? And then what is the next quadrant I would rotate through? And what is the last quadrant I would rotate through? The reason we number the quadrants this way is because the definition of an angle, starting on the positive x-axis, rotating counterclockwise, takes me through the quadrants in that order. Are we done talking? Okay. Now, here's the thing. How many of you have gone, like, say, to a coffee shop or something, and you order coffee and they tell you they want your name to write on the cup, right? Okay. This happens to me all the time. That's the one I get. Is that me? No, that's not me. That's not me. Anyone have that problem? This is me. This is me. Oh, that's not me. This is me. This is me. This is not me. It sounds the same, but is it me? No. Anyone else have that problem when you go to they get your name wrong all the time? Okay. This is not me. Hey, you haven't been with me long enough to know this is actually not just me ranting about Starbucks. This is going to actually tie to math. Whoa. You weren't planning on passing, were you there, sir?
No, I meant your way. The way that's not crossed out.
Fair enough. This. Are we paying attention? This is not its name. Doesn't that say quadrant 2? Doesn't that say quadrant 2? What do you mean that's not its name? Quadrants are named with Roman numerals. If you give me non-Roman numerals, you are not getting the name right, okay? It should be quadrant 2, okay? They are named with Roman numerals. What? Okay. So if you told me quadrant 2 on the quiz and you wrote it this way, are you going to lose points? Yes, because that's not its name. Okay? You have to know the Roman numerals. Any questions on that? Do you have a question? Okay. All right. So a central angle. I got a circle here. Is that about the center of that circle? Okay. So a central angle is going to be an angle with its vertex at the center. Okay. So for a central angle, so this is theta. Okay, it is a Greek letter. Most of the time, we're going to be naming our angles theta. It is the most common or most commonly used Greek letter for angles. And in this case, theta is a central angle. Okay. Do you see that the vertex is at the center of that circle? What is this length and that length? What are those? Those are the radius, the radii. So this length is the radius. Okay. And I'm going to call, actually, I'll make it green. This S is the arc length. Okay. This angle that I rotate through, this is the amount of that circle that is cut off by that angle. And that would be the arc length. Okay. So this is just language. S subtends theta. Okay. That's just the language that's used for S is over theta. It's the arc that's marked off by theta. Or theta is subtended by S. Okay. That's just vocab. It just means that the arc is over that angle. That's all it means. Okay. So we are going to learn a new measure. 1 radian. Oh. So 1 radian this is theta, this is R, this is S, right? 1 radian is the angle, marks off an arc that is equal in length to the radius. So if I took this length, ran it around the circle, and that's where I mark off the angle, that is considered 1 radian. Not a degree. Degrees are significantly smaller. So if I took, I want to see how close I got. So if I took this measurement, that long, and I ran it around the radius, this curve it around there, the angle that's created by an arc length that equals the radius is called a radian. Okay. So if
S equals arc, then it's a radian. Is that what you're saying?
the angle is 1 radian. I'm just trying to get this written down. I was going to do this, but yeah. So the measure, 1 radian is the measure of a central angle subtended by an arc equal in length to the radius. Okay. This is a new unit of measure, and this is the unit of measure for angles that you will be using exclusively in calculus and when we get back from spring break. Okay. So this rotation here, how much in degrees is that rotation from here to there? That's 180 degrees rotation right here, correct? If I go there. So now I'm going to mark off 1 radius, 2, 3. So, oh man, so 180 degrees is approximately 3.14 radians. No! Wait a minute. 180 degrees is pi radians. So what is 1 full rotation of my circle? 360 degrees is 2 pi radians. Now, here's something you have to be careful of. 180 does not equal pi. That one's really easy. Pi is approximately 3.14159, etc. That is not 180, and that is not anywhere near 180. Just like 12 doesn't equal 1, but 12 inches equals 1 foot. So with the units of measure, this is a true statement. This is not, don't say 180 equals pi. That's not true. But 180 degrees equals pi radians, okay? Does that make sense? So I find this really interesting that if I make 1 full rotation, I'm going to rotate through 2 pi. Isn't that the formula for the circumference of a circle? I rotate through 2 pi radians, which is equal in length. The radian is equal in length to the radius. So that would get me the circumference. It's almost like it comes from that. It does. Okay. So now that we have a new unit of measure for angles, we need to be able to convert back and forth between. How many of you have taken a science class where you've done dimensional analysis? We are going to use dimensional analysis. Mr. Wanick would be proud. Oh, if you couldn't do this? Okay. So let's start with 36 degrees. Okay. So with dimensional analysis, I am going to be multiplying by a form of 1. 12 inches over 1 foot, right? Units of measure. So the units of measure that I know are equal to each other is 180 degrees and pi radians. So if I divide 180 degrees by pi radians, what am I going to get? 1. They're equal measurements, aren't they? Right? Different units of measure, 12 inches, 1 foot. So I have degrees. I need to divide out the degrees, correct? So I'm going to divide out the degrees, and then I need to introduce in radians. And now I put the numbers where they go. 180 degrees, pi radians. Do you see how I did the units of measure first? What is degrees divided by degrees?
They cancel each other out.
They divide out, don't they?
Or they divide out, whatever.
Okay. So now I am only left with radians. Does that make sense?
Yeah.
Try this one. 280 degrees. Let me get you started. I'm going to help you out. I could say this is over 1 if that helps. Do the conversion.
Never mind.
Is this what we got? And I can divide both of them by 10, and then 28 over 18 is going to get me 14 pi over 9 radians, or you can say 14 ninths pi. Those are the same thing. Those are the same thing. I don't care which way you say it. I usually write the pi with the numerator, but it's still a fraction of pi. Okay? So now that we understand that, what if I asked you to convert 6 pi over 5 radians? How am I going to do that conversion? I'll get you started. What don't you understand, Jabin? 36 divides into 185 times.
Isn't it 1 over 5, something over 5? Yeah. Degrees.
Did we make that connection? We needed to divide out the unit of measure radians, and we needed to introduce in degrees. So radians divides, and I'm left with degrees. Oh, and my pi divides out, so I now have 216 degrees. Does that make sense? Try this one. Do 8 pi over 15 radians. Is that what we got? Okay, so I reduce radians, I reduce pi, and I'm going to take 8 times 180 divided by 15, 96 degrees, right? Now, after doing these 4 examples, here's what kids make a rule of, and you need to not do that. So obviously pi is the unit of measure for radians. No, pi is a number. Pi is not a unit of measure. I can ask you, I'll do blue here, 6/5 radians. Is there a pi in there? Should you put one in? No, it is not a unit of measure. Pi is not a unit of measure. It's a number. Radians is the unit of measure. Doesn't matter if it has pi in it or not. I'm going to do the same thing we just did. I need to divide out radians and introduce in degrees. So 180 degrees over pi radians, I am going to get 216 over pi degrees. Pi doesn't mean you have radians. Pi is a number. If I say something is in radians and it doesn't have a pi in it, don't think I missed it. Don't stick it in there. You just took the number I gave you and multiplied it by approximately 3.14. Pi is a number. It is not a unit of measure. Okay? All right? Any questions on that? Okay. So, coterminal. Oh, I wanted to write one statement. I wanted to write this down. Okay, pi is not required for a radian measure. So, coterminal angles have the same initial side and the same terminal side, and they differ by a whole number of revolutions, correct? So if I gave you 2 pi over 5 and I said I wanted you, let's call this theta, I wanted you to give me a positive and a negative angle that is coterminal to 2 pi over 5, that means, let's do the positive one first. That means I have to add at least 1 full revolution. In radians, how much is 1 full revolution? 2 pi. Now, because we are not very good with fractions, you have to get a common denominator. Do you agree that 12 pi over 5 is not equal to 2 pi over 5? But are they 1 full rotation apart? So that is a positive angle. Could I have added 4 pi? That would be 2 full rotations, right? Could I have added 3 pi? That's 1.5. I need a whole number of rotations. I could have added 100 pi, but most of us are like, I'm just going to start with the easy one. So how would I find a negative coterminal? Oops. So I'm going to subtract 1 full rotation. Which gets me a negative angle coterminal. If we were in degrees, how much would we add or subtract? Or a multiple of 360. 360, 720, right? We would add a multiple of 1 full rotation. Does that make sense? Okay, we have 5 minutes left. I don't think I'm going to be able to get to that. So this much right here, I think I need like 7 more minutes. I'll make a video on arc length and I will post the assignment. It's out of the book. And then again, I'm going to try to get angular and linear velocity video done